Okay, so this will be on tomorrow's quiz. All right, so first of all, let's just remember, all right, that this is true for all triangles in our geometry. The interior angle sum of a triangle. Okay, so what is the interior angle sum of any triangle that we deal with here? What do you say? What is it? 180 degrees? So, all right. The interior angles of a triangle, all three angles that are inside a triangle, interior means inside, so the interior angles of a triangle, okay, add up to 180 degrees. All right. And in fact, other shapes also have angle sums. So for example, quadrilateral, four-sided shapes, okay, they also have an interior angle sum. Zach, do you have some? Okay. Okay. So quadrilaterals also have an interior angle sum as well, okay? And actually, does anyone know what quadrilaterals interior angles add up to? It's 360, that's right, okay? And a pentagon, it has an interior angle sum. And a hexagon, heptagon, and octagon, those all have certain sums, but triangles specifically have 180 degrees for their sum. Okay? Don't forget also the exterior angle theorem. Okay, this is one of the ones we talked about. Again, I know we were kind of reviewing this. This is something we've already seen, but I want to have it written down again. Okay. An exterior angle of a triangle is equal to the sum of the two remote interior angles. Okay, an exterior angle of a triangle is equal to the sum of the two remote interior angles. Now this one I feel like it's helpful to draw a picture. So let me draw a picture of this. Okay, so I'll draw a triangle here. Just use this to help me draw my... Okay, so we'll call this angle 3 right there. And I'll call this angle 1, and here I'll call this angle 2. Okay, so I'm going to use numbers to name these angles. Okay, so that's angle 2, that's an angle symbol, and then angle 1, and that's angle 3. So angle 3, that's an exterior angle. Exterior, it's on the outside of the triangle. Okay, it's made by extending a side, and then it's the space between that extended side and another side of the triangle there. And then these two, angle 1 and angle 2, those are the remote interior angles, right? They're remote because they're what? They're far away. They're far away from 1 and 2 are far away. This angle right here, we would say it's the adjacent interior angle, but we're not going to name that because it's not part of it. So here, in other words, your exterior angle, angle 3, is equal to angle 1 plus angle 2. Okay, that's the idea there. Exterior angle is equal to the sum of the two remote interior angles. Okay. So that's all review right there. Okay, that's all review stuff we learned back on Monday, I want to say. Okay. So now let's get into the actual classification, though. Okay, so classifying triangles by sides. We're going to look at classifying it by sides first. Okay, and there's 3 different ways we can classify triangles by their sides. All right, so I'm going to again sketch this one out here. All right, so we'll start with the triangle. The one you guys probably first saw when you were like little bitty babies, and your parents were like, I'm going to make my child the smartest child ever. I'm going to teach my child their shapes before they get to school. And this is the first triangle you probably ever saw, okay? And your parents did a really good job, and they're like, okay, this is a triangle. And so all your life, you're like, that is what a triangle looks like. But we've seen other triangles than that, right? So there's actually a specific name for this kind of triangle. When all the sides are equal, what do we call that? I heard it. Equilateral. Equilateral. You're onto something else. That's another one. Yep. But equilateral. So your parents probably do not teach you that word. They're just like, that's a triangle. And they're right, it's a triangle, but it's a very specific kind of triangle. It's an equilateral triangle. The definition, okay, its meaning is right in the word. Equa, what do you think that means? Equal, right? And a lateral, well, you football players, when you do a lateral throw, right? That's either behind you or to the side, though, right? It's to the sidelines, right? You can't throw it forward. You have to throw it to the side or behind you. And so that's the idea. Equal sides, equilateral. Okay, the definition of the word is in the word right there. All right. So then we'll move on here. All right, we got another triangle. We'll try and draw this one, okay? I'm just changing it up. I don't always like to draw my triangles like a base on the ground there. All right, so we got this triangle, and let's see here. I'm going to show, so this and this side. Those are the only, so we only have two congruent sides here. Only two congruent sides. And what kind of triangle is this? Yes, isosceles. That was the one you were trying to say, yeah. And this is isosceles, and unfortunately this one does not have a nice, easy way to remember it. Okay, isosceles. I-S-O-S-C-E-L-E-S. And don't worry, on tomorrow's quiz, actually, I should make spelling count on tomorrow's quiz because you do have your notes, but if you misspell it, it's not a big deal, okay? It's not a big deal. But it is kind of like, well, you have your notes. Why did you misspell it? But anyway, okay. Okay, now, when you have an isosceles triangle, there are parts to the isosceles triangle. For example, this side and this side are both known as legs. So these are the legs of the isosceles triangle. They're the two congruent sides. They're called the legs. All right, so those are called the legs. Additionally, and this is going to be weird for some of you, you might feel uncomfortable about this, the bottom side, or sorry, not the bottom side, this third side here, this is known as the base. Okay, and it's called, well, because I think a lot of us, it's uncomfortable, I think, because the base we normally think of being on the bottom of something, but it doesn't have to be on the bottom. If you see the way I have my triangle kind of like oriented here, the base is on this side of the triangle, okay? But it's the base because it's not the two congruent sides, basically. Okay? In addition to that, so since this is the base, the two angles that are touching that base, guess what we call those? If they're touching the base, we're going to call these the base angles. So this angle right here and this angle right here, they're base angles because they kind of touch the base. And again, you'll see why we're naming all these things here in a little bit. And believe it or not, we don't want to leave out that third angle there. That third angle actually has a name. The third angle right here is called the vertex. The vertex angle. Okay, V-E-R-T-E-X angle, the vertex angle. All right. For whatever reason, the isosceles triangle has all these names attached to it. The equilateral triangle, not so much, okay? And then the next triangle we're going to look at, not so much either. Okay, so I'll go ahead and draw this next one here. All right. So we went from 3 congruent sides down to 2 congruent sides down to... Yeah, there's, in other words, or no congruent sides because they're all unique, okay? And the word for this triangle, when all the sides are different lengths, is scalene. Whoops, got ahead of myself. S-C-A-L-E-N-E, scalene, okay? No sides are congruent there. So, and there's no names for anything, it's just, there it is. Okay? All right, so that's how you classify by side. Let's also look at classifying by angles. All right, so that's all the different ways you can classify by sides. All 3 sides congruent, only 2 sides congruent, no sides congruent. And then finally by angles, well, we'll draw another similar shape to what we just saw up there. Okay. So there's our next triangle. By its angles, well, all 3 angles are equal, so, well, we could call it acute, yes, so I'll put that in parentheses here. It's not wrong to call this triangle acute, but more specifically, what can we call this triangle? Not equilateral, equal sides. We need angle. Yes, equiangular. Equiangular, that's it. Equiangular. Now, was Coignet wrong when she also called this triangle equilateral? She was not. No. If a triangle is equiangular, it must be equilateral. Okay, so she's not wrong in saying that it's equilateral, because it is. It will be, okay? And in fact, when a shape is both equilateral and equiangular, and this is one of the silliest words that we use, I feel like it's actually a very special thing, but we call that shape regular, okay? So this is a regular triangle is what it's called, okay, which is really silly to me because, again, I feel like regular, well, this is very special, and regular does not really indicate something being special, but there it is, okay? So it's equiangular, equilateral, same, they're both the same, and so it's a regular shape, okay? Later, when we talk about polygons, there are polygons that can be equilateral, but not necessarily equiangular, or they can be equiangular, but not necessarily equilateral. But for a triangle, it's got to be both. You can't have one and not the other. Okay.
What if they refuse to call it equiangular?
What's the other option they're going to call it? So calling it acute is not wrong. I would still give you credit there, but the more precise term would be equiangular. And if you call it equilateral, well, yeah, that's not wrong either. But again, if I'm classifying it by the angles, you need to use equiangular or acute there. Okay. All right. What would this triangle be called?
Two-angle Joe.
Two-angle Joe. Okay. So this one's acute. This one's acute. Okay, this one's acute. Okay, why is it acute? All the angles are what? Are less than 90 degrees. Okay, so yeah, in this case, my triangle looks isosceles. Now, granted, it's not marked that way, so we want to be careful about assuming it's going to be isosceles, but yes, absolutely. This triangle up here that I marked isosceles, it looks acute as well, does it not? Because of the angle sizes and stuff like that there. So yeah, it is. It looks like it's an acute isosceles triangle. It's acute isosceles. Okay, so there it is. All right, next one. Okay, what do we call this triangle? You're right. That's right. It's right. Okay, it's right because one angle is 90 degrees. Okay. Scaling, we'll get to that. That one's not right, right? Correct? Okay, yeah, it's not, this one's not right, yeah. But this one is. This one's right, okay. Is it possible to have two right angles in a triangle?
No. Yes.
Why not, though?
You don't know.
Because it's going to be like a weird shape.
Well, so we can talk about it this way. So Zach brings us a good point. What do all the angles in a triangle have to add up to? 180. And how many angles are in a triangle? 3. So if two of those angles are 90 degrees, 90 plus 90 is 180, so the third angle would have to be
A negative.
No, it would be 0 degrees, which would make no sense, right? Or even a negative angle would really not make sense in the shape, too. So right, the idea is you can only ever have one right angle unless you're talking about other geometries, and in other geometries you can have triangles with more than one right angle. But in this case, for our geometry we're working with in this class that we're learning about, you can only have one right angle. Okay? So. All right, and then last but not least, okay, something like this. All right. It's obtuse. That's right. It's obtuse. Okay? And it's obtuse because one angle is what? Is more than 90. But again, is it possible to have two obtuse angles in a triangle?
Yeah.
Is it possible to have two obtuse angles in a triangle? And the answer, yes, no. If we can't do 90, if we can't do more than 190, we definitely can't do more than one that's greater than 90. Okay? I forgot, one thing I wanted to point out here, in a right triangle, I want to name some things, okay? This side right here is the hypotenuse, right? It's opposite the 90-degree angle. Right? And then these two sides right here are the legs. Okay, of that right triangle, just so you know that too. Hypotenuse is always opposite the right angle, and then the other two sides are the legs. They are adjacent to the right angle. They touch the right angle there. Okay? All right, so I'm going to give you just one little example here, and then we'll do some together here as a class. I want you to try this. So triangle ABC. Triangle ABC, okay, I've got AB. Its length is 1.5. Okay, I have BC, and its length is 1.3. And I have AC, and its length is 1.8. Okay. And then I have angle C. It has a measure of 55 degrees. I have angle A. It has a measure of 45 degrees. And then I have angle C, and angle B. I already did angle C. Angle B, and that is 80 degrees. Okay, I want you guys to classify the triangle by sides and angles. Okay, so go ahead, take 30 seconds, give them that information, or a minute, okay, and think about what that triangle must be by its size. Is it equilateral? Is it isosceles? Is it scalene? And then I want you to also look at its angles, okay? By its angles, is that triangle equiangular? Is it acute? Is it right? Or is it obtuse? Okay, so look at those real quick. Take 30 seconds. Okay, and tell me if it's going to be one or the other there. One or the other.
I want to
Okay, so again, is it one or the other? Which one is it? Is it isosceles? Is it equilateral? Is it scalene? Is it angular? Right? You can still tell. So let's see, is it equilateral? How do you know? Why does it sound equal? Okay, so if I have three of the same number, they're all equal. We got three different sides. One, two, three.
How many sides are you?
Three sides that one triangle.
None of them, right? 1.5. We're just trying to know how many right?
All right. Time's up. Time's up. Here we go. Let's go to Juanye. Please, would you answer the question by its size? Just tell me by its size. What is that triangle going to be? Shh. All right. Juanye says it's scalene. Does anyone disagree with that? Silence. So either you don't care or you all agree. And the answer, yes, you're right. It is scalene. That's right. How'd you know, Juanye?
Because all the sides do not match.
Yeah, all the sides are different, right? AB is 1.5, BC is 1.3, AC is 1.8. Completely different. You could draw a picture here if you wanted to, but it's not necessary. You can just see. They're all different. All right. One second, Alex. Let me get some more. Actually, go ahead. Alex, your turn. Angles, please. Angles. By the angles, Alex, what would the... Acute is correct. That's right. How do you know?
Because none of them are even 90 degrees.
Right. They're all less than 90 degrees. They're all acute angles. So yes,
But
acute.
no, I was trying to say, like, you know how we doing the sheets with that
Right.
SA.
Right, all the congruents.
The triangles really, like, technically wouldn't be yellow, like, because it had, like, triangle ABC.
Congruent to something else.
Yeah.
Right. So in this case, we're only looking at individual triangles, not trying to show two triangles are congruent. So we're looking more at just the individual parts, not showing that parts of one triangle are congruent parts of another triangle. So this is a little bit different, but it's still doing triangles and stuff, so that's why I like to do it. All right, so let's take a look here at this. Okay, so I'm going to zoom in here on one triangle at a time and try and identify it. Okay, so actually, we'll look at this one for an example. All right, so for example, here is an example of a scalene obtuse triangle. Let's look at number 2. Okay, right there. So again, in your minds, think about this one, and I'll call on someone. In your minds, I want you to think about, okay, what is this triangle by its sides? What is it by its angles? And then we'll call on someone. So just think about it right now. All right. About that. What is it? What is it? All right, Gabe, what do you say there? By its sides, what is it? Equilateral. And by its angles? Equiangular. Very good. That's right. Okay. Let's move on. Number 3. Okay. So again, take a little snapshot there in your mind. Okay. Let's see. Ooh, I don't know. I need to put a protractor out. Ooh, all right. I don't know. Let's go to column W. Okay. By its sides, column W. What do you say? Is it equilateral? Is it isosceles? Is it scalene? I'd say isosceles there. Yeah, it's kind of hard to see, right? Might be scalene, definitely not equilateral. So I'd say isosceles. I like isosceles. Yep, great. Okay, let's go to column S. By its angles, column S, what kind of triangle does it look like? Does it look like it's acute, right, obtuse? Looks like it's right. Yep, I'd say it's right as well. Yep, so we have a right angle there. So it's a right isosceles triangle. Right isosceles. Okay, cool. All right, let's go to... Ooh, these are all kind of similar here. Let's go. Okay, here we go. Go to this one. Okay, number 8, or this one right here. Okay, it's number 8. Again, look at that triangle. Identify it by its sides, by its angles in your mind. In your mind. All right, Zach's not here. Went to the bathroom. He escaped. All right, Jason. What do you say here by the sides, Jason? Isosceles. Very good. Okay, 2 congruent sides. And then let's go to Jake. Jake, what about by the angles there? Acute. Yeah, it's a cutie. Okay. Number 9. Okay. There's one time in the book somewhere, in one of these books, you have to identify that angle BAE is acute. So Bay is acute. I thought it was kind of is a cute angle. So anyway, I don't know. Thought that was kind of funny. Anyway. Okay, moving on. I was the only one. And Josh laughed because of sympathy. Or not Josh. Eli laughed for sympathy. All right, Josh, your turn here, Josh. By the sides. By the sides. By the sides.
It was all her.
Debbie? Oh, Debbie laughed? I thought it was Eli that laughed. I'm sorry. Debbie laughed. Never mind. I thought it was Eli. I thought it come from this other direction.
Oh, my chuckle.
There was an angle BAE, and it's less than 90 degrees, and so in the book you have to identify BAE as acute. So Bay is acute. Yeah. Bay is acute. Yeah. So it's math. I don't know, and it's not a joke. I mean, it's like there's an answer, but I thought that was pretty interesting that they had that work out that way. I did it on purpose. Anyway, Josh, by the sides here, what would you say? Is this triangle here? Is it scalene? Is it isosceles? Is it equilateral? Which one? By the sides. Scalene. Isosceles. You could say scalene there. I don't know. It's hard to say. I might also want to say isosceles, but I think scalene is the better way to go there. I think it's probably scalene. Yep. Looks scalene to me. Okay, and then by the angles, let's go to... Oh, Ray's not here. He left. Courtney's not here. Robbie's not here. All right, let's go... All right, hold on a second. We'll just go this way. Debbie! Go ahead, Debbie. Huh? By the angles.
Okay, by the angles?
Yes. Obtuse. Yes, don't be obtuse. There you go. All right, number 10. Let's go to Mitchell, number 10. Okay, sides are what? By sides, it's what? Oh, sorry. By sides, it's what? Oh.
Oh, you meant
sides. Sorry. Shh. Scalene, and by its angles, acute. That's right. It's acute scalene triangle. Okay. And woo, stop there. Okay, so that's that. So yeah. So what I'd like you guys to do then is get your books out. There's a few properties of isosceles and equilateral triangles I want to look at. So on page 327. Page 327. Yes. You need your book, right? Oh, hang on. I might have a spare thing I can get you here. 327. 327.
Why would you do that?
Page 327 in your book. Okay, so on page 327, you can see that this title, the section here is called Isosceles and Equilateral Triangles. We're not going to spend a ton of time, we'll look through the vocabulary here because we already just learned it, right? But so just remember, right, when we talk about isosceles triangles, an isosceles triangle is a triangle with at least two congruent sides, all right? So at least two congruent sides means that if you have an equilateral triangle, so if I have an equilateral triangle, does that have at least two congruent sides? Yes. So is this shape also, what else we call this? Besides an equilateral triangle, we could also call it an isosceles triangle, okay? Because an isosceles triangle is a triangle with at least two congruent sides, okay? So we could call that triangle also isosceles. All right. The congruent sides are called the legs of the triangle, right? So here in a typical looking isosceles triangle, this is congruent to this. Oh, yeah, right here. There you go. And then the angle formed by the legs is the vertex angle. So there's the vertex angle up there, right? And the base, that's the non-congruent side. The side opposite the vertex angle is the base. And then these are the two base angles there. Okay, we won't do the activity there. It's pretty straightforward. Now, here's something I do want to point out, though. All right, so turn the page there to page 328 and look at the bottom. Okay, and we have this theorem, which we have not talked about yet. Okay, but it'll kind of make sense, and we're going to prove it to be true, actually. So, if two sides of a triangle are congruent, so if we have an isosceles triangle, if two sides of a triangle are congruent, then the two angles opposite those sides are congruent. Okay, so if we have an isosceles triangle, we don't only have two sides that are congruent, we also have two angles that are congruent as well. Okay, this is sometimes called the base angles theorem. You can see it right there. So base angles of an isosceles triangle are congruent, in other words. So if we look up here, we're actually going to prove this to be true. Okay, so we're going to prove the isosceles triangle theorem and its converse. Remember, converse is when you just flip the if-then statement around. So we're going to complete the proof here. So we're given a triangle here, and we're told that AB is congruent to AC. Again, on page 329 is where we are. So AB is congruent to AC, and it's marked in the picture there. Okay, and we want to prove that angle B is congruent to angle C. All right. So we start out with the given information there. BA is congruent to CA. Okay, that's what you see in the picture. Okay. The next step in the proof, they say that angle A is congruent to angle A. Well, what's the reason that we can say that angle A is congruent to angle A here? How do we know something is congruent to itself? What's the rule? What's the thing that we use to say that? Reflexive property. That's right. Because it's something is congruent to itself. Angle A is congruent to angle A. So the angle A in this triangle is congruent to itself. Yeah. Yes. But the reason why we're doing that here. Listen up, folks.
No, I thought we had two, A, B would be or A, B.
Congruent to AB. Yeah, so you can do it for sides, but it also works for angles too. You can do it for angles too. We haven't done it with angles a whole lot, I'll say that. We haven't done it with a whole lot of angles ourselves. But, so there that is. Okay, angle A is congruent to angle A, it's shared. So the idea here, what we're going to do, what we're doing in this proof, is we're proving that triangle BAC is the same as triangle CAB, which might seem kind of like Well, dumb is the same exact triangle, but it's going to be part of this proof here. So these two triangles then are going to be congruent because we have a side, an angle, and a side here congruent. So it's side, angle, side congruence. Okay. And then since this triangle is congruent to this triangle, all right, we can say CP, CTC, that angle B, right, will be the same as angle C because they're both in the same position. Okay? And so that just goes to show you that if we have two sides of a triangle congruent, two sides, AB and AC congruent, then there are two opposite angles, B and C, the base angles here, right? Opposite the congruent side here, opposite the congruent side here. B and C are also going to be congruent then. Okay, just like that. Okay, so angle B will be congruent to angle C if we know that AB is congruent to CA. Okay, likewise, okay, if you can look down here at the next picture, we won't do this proof just because I feel like it might not be that helpful, but if we have two congruent angles in a triangle, then the opposite sides will also be congruent. So if we know that B and C are congruent, AB and AC, they're opposite sides, right? Opposite B is this side, opposite C is this side, they will be congruent as well. Okay? So that's the idea there. All right. So let's turn the page here. And now we're going to look at equilateral, equiangular triangles. I already told you about this, though, right? This is something we've seen. An equilateral triangle is a triangle with three congruent sides. An equiangular triangle is a triangle with three congruent angles. If a triangle is equilateral, then it's equiangular. And likewise, if a triangle is equiangular, then it's equilateral. We won't prove it, but we've already seen that. That's it. Okay, that's the idea. Yep.
Is this with recording, like, community?
Yes, for you guys to see tomorrow or later if you want to. Yes.
Yeah.
Yep. Okay, so moving over here, let's do some actual problems. So how we're going to use these properties. Okay, so you can use the properties of isosceles and equilateral triangles to solve problems involving these theorems. All right, so find the indicated measure. That's our direction here. So Katie is stitching the center inlay onto a banner that she created to represent her new tutorial service. Okay, for whatever reason, because we need it to be, it is an equilateral triangle with the following dimensions in centimeters. Okay, so it's asking us what is the length of each side of the triangle. So given this situation, it's an equilateral triangle. Okay, we want to find the length of each side of the triangle. Well, what's true about an equilateral triangle? Its sides are what? All equal. So what's the equation we can set up here given this information? So I want to raise your hand and tell me what's the information we can do. Yeah, Alex, go ahead. What's the equation we can set up here?
You can set up really be 6x minus 5, and then I think the equal sign.
Yeah.
And then 4x plus 7.
You got it. Exactly right. If this is an equilateral triangle, we're told it is, all the sides have to be equal. Well, if this side is listed as 6x minus 5 and this side is 4x plus 7, then they need to be equal to each other. Exactly right. Okay? And so then go ahead. Can you solve it for us too there, Alex? What should we do to both sides here?
I think would you minus the 7?
We can do that. Let's get our x's together first. Let's get our x's together first. So I either need to get rid of the 4x to bring it over here, or I need to get rid of the 6x to bring it over here.
We should get rid of 4x.
Yeah. Let's get rid of the smaller of the two. That's right. So we'll subtract 4x from each side. Okay. 6x take away 4x is 2x. Bring down that minus 5 there. And then equals 7. Okay. And now what, Alex?
Then we want to do the reverse 5, so we have to be plus 5.
Plus 5, both sides. You got it. So that's gone. We're left with 2x equals 7 plus 5 is 12. And then last step here.
Don't you got divided?
Divide by?
2.
2. You got it. Okay, so x is 6. Okay, so is 6 our final answer here?
No, actually.
No, because we're asked what is the length of each side of the triangle. So what do I got to do with this 6? Plug it back in. Does it matter which one I plug it into?
Not really, no.
It won't. It won't matter actually. So let's try. Let's do 4 times 6 plus 7. 4 times 6 is 24. Plus 7 is 31. Let's check it in here. 6 times 6 is 36. Minus 5 is also 31. So there, 31 is the answer. 31 centimeters, I guess, because that's what we're told there in the problem, that their length's in centimeters. So 31 centimeters is the final answer there. Okay? All right, we'll do one more here, and then I'll get you guys started on your assignments. All right? So, yeah, it is written right there. That's right. Would you prefer to read it, though? I feel like when we
I
just...
didn't know, I didn't read it wrong.
Well, I prefer... we could just read through it, but I feel like reading through it is not as helpful as actually doing it ourselves, too. We can see, like, yes, that's the answer. We should have gotten 31 there. Okay? The next one, though, Alex, we have to do anyway, because it's blanks and
Oh,
stuff.
I see you calling me.
No, I'm not calling it yet. No. All right, so this one. Okay, in this triangle, there's no more situation. We're now just in a random problem here, okay? We want to find the measure of angle T. All right? What kind of triangle are we dealing with here, Corey? What kind of triangle is this here, Corey? Based on its size, what kind of triangle is this? It doesn't look equilateral to me. Based on how it's marked, I only see two sides congruent here. So what do we call a triangle with two sides congruent? Isosceles, yes, it's isosceles, yeah. It's isosceles. So this triangle is isosceles. So, but we want to find the measure of angle T here. What else can we mark in this triangle here? So if I know that, yeah, I'm not sure, what can we do here? Because we need to figure out an angle, but all we know is that these two sides are congruent. But yeah, Corey? Find this angle?
Yeah, you find that divide from 180 and divide it, or you get by 2.
Divide 180 by 2?
No, whatever you get from the
Right, and the problem is though we don't know what this is just yet, so we can't find that angle yet. We need to figure out what x is. Yeah.
Wouldn't figure out. I thought it was a right angle.
Yeah, it doesn't quite look like it's a right angle. We don't want to assume it is because we're not told this is a right triangle. We just know it's isosceles based on the picture.
It's 280 divided by 3.
Okay, close, but I only see two angles listed here, right? What can we call this? What can we say this angle's measure is going to be? Debbie? Yeah, it's got to be x. It's got to be x, right? Why? Because it's opposite a congruent side there. If this angle's x and it's opposite this side, then opposite this congruent side, this angle also has to be x. These are the base angles. They have to be equal. Okay? So now we have all three angles in this triangle, and we know all three angles in the triangle have to add up to what? 180. So we can say x plus 3x equals 180. X, and 3x equals 180. Okay? So x plus 3x, that's 5x. Okay. And so then to finish solving this, all right, to get the x by itself here, what are we going to do? Let's go to Tristan. What would we do here, Tristan, to finish solving this equation right here? To get the x by itself. Divide by 5. You got it. Good job, Tristan. Exactly right. And dividing that by 5, we get 36, I think. Okay. So Tristan is the answer 36. What do we still have to do? Plug it right back in up here. Angle T, the measure of angle T is 3x, and we want to plug in that x in, so it's 3 times 36. Okay. And 3 times 36 is 108 degrees. So, is this triangle a right triangle? No. What is it by its angles? Obtuse. Obtuse.
We wouldn't plug in like, if I would have said that, we wouldn't plug in the 2 x's, you couldn't put the 36 for those two?
You could, absolutely. You could. So we could say that this angle is 36 degrees, this angle is 36 degrees, but the question was asking what's the measure of angle T. But no, that's absolutely right, you can. Okay. And notice here, folks, be careful. If you just look at angle R here, you might be tempted to say this triangle is acute. If you only look at angle R, you might be tempted to say this triangle is acute because you see, oh, 36 degrees, that's less than 90, this triangle is acute. You have to look at all the angles, though. If just one of the angles is obtuse, we call the entire triangle obtuse. Okay? If just one of the angles is 90 degrees, we call the entire triangle a right triangle. Okay?
Where have the
Yeah.
box that is 90 degrees?
Yeah, it should, but sometimes they won't draw it in especially if you're solving for it. Because if you're solving for it and you see the box, you're like, well, I know it's got to be 90. You know what I mean?
Because I'm saying, because on the worksheet, if you have the homework, they
Yeah.
have, like, some of them didn't have things we have to draw from that.
Right, exactly. So, yes, keep your eyes out for that. Okay, your assignment then, your assignment. Here we go. What I'd like you guys to work on is page 334 to 337. Okay, now I'm not going to give you all these. Okay, it's not all of them. I want you numbers 4 through 8, number 10, and then 18 and 19. Okay, so 4, 5, 6, 7, 8. 8 problems total. Okay, 8 problems total. So if you would please go ahead and give those a try.
Okay, yeah.
Yep.